let us learn about stacks. Okay, who will give me the best one-liner definition on stack? All of you have seen the stack of books or the stack of plates. What is it that is so unique about it? So what happens in a stack of plates or stack of books or whatsoever it is? So the first plate to be inserted was P1. And now whenever some guest comes and pulls a plate, he will never pull P1 first, right? He will always pull this one first. Let's say above P4, P5 had come. So he would have pulled P5 first. So whatever is last in, that is first out. And whatever is first in, that is last out. So whenever you need such kind of thing, that whatever comes at the end, that should be removed first, then stack kind of data structure is very helpful. So this is also called as last in first out or first in last out data structure. Okay, have you seen some real life use cases of this principle? In fact, I have talked about it in the classes. So what are some real life operations of this? Undo operations, and apart from that, browse the back button, recursion, great, call stack, great, yeah. So whenever you implement recursion, then what happens? The flow of function calls is from top to bottom, but the return is from bottom to top. Why? Because you want the function which was called at last to exit first, and you want the function which was which called something in the beginning to exit when all its children are done. So recursion call stack is a LIFO stack. So because of this thing, any question that you can do using recursion, you can also do using stack. And this statement I am making it very confidently over here. Sometimes implementation can be very easy while using a stack. Sometimes they can be a bit complicated, but you will be able to do it at the end of the day, because inherently your system creates a stack. It's nothing different from stack. What actually happens is creation of a stack to implement that recursion. Recursion is not a magic, it's just stack behind the scene. Okay, so keep this thing in your mind forever. Cool. Undo operation also, very good. So I think that again makes a lot of sense. So let's say there is a Word document. So whenever you are playing with Word document and doing some events on top of it, events can be copy, paste, write, it could just be anything, right? So let's say you write a word over here. So initially you had a blank sheet and now you wrote a W over here. So you will have this with a W, and now you wrote R over here. So you will have a W followed by R. Now let's say you do an undo. So when you do an undo, you would want to come back from this to this, and now you can easily come back from this to this by just removing this thing from the stack. Now what happens when you remove this thing from the stack? This is thrown into another stack. Can somebody tell me why is this thrown into another stack? Why doesn't your system just let go of it? Very good. Because you might want to redo. So if you want to redo, this can come back over here. So these undo redo operations are actually implemented using stack. So whenever you want to work around with the last considered element, then stack is very, very helpful data structure. So that is an important point to make. Another point to make is, so stack is such a kind of data structure whose one end is permanently fixed. So one end will not move, just the other end can move. It can go up, come down, go up, come down. So you call push, 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 it goes up. You call pop, 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 it comes down. So these are few important things about stack. One end will permanently be fixed. So this brings about, you know, some not so cool things about stack also. Few of those things are that if let's say you need to do some operation at this end, then it will be very costly. But if all your operations are based on this end, which is the dynamic end, then stack is wonderful. So given a question, identify such things. Identify whether I can just work on one end or do I have to move this end also. So based on that, you can choose the right data structures. I'll tell you when both the ends are flexible, then what is the better data structure to be used. Cool. So before jumping on to, I think, using an STL stack, you should first create your own stack if you have not ever created, but I think that is quite rare. So stack that you have, any stack. First thing to be implemented, it needs some space. The space can be a linear array. And what is second thing which is most important? Second thing which is most important is top variable, which will help me know that hey, elements are there till this point and now whatever comes should come before it, and so on and on and on and on, right? So whenever you push something, it comes at the top, and whenever you remove something, the top gets neglected and you come down. This is how it goes around. So if you use a structure, you can have a structure called stack, and then here you will have an integer array of some predefined size. Let's say somebody assures you that hey, your stack will never grow more than 1000, so you can have it as 1000, and then you can have an int top. Okay, and then you can create a variable of this struct stack s. So the moment you do this thing, there are two memory allocations that happen, one memory allocation for this array and one memory allocation for this. So 1000 plus 1, there are 1001 integer specific memories that get allocated. Okay, now what will be the important operations on stack? Important operations on stack will be to insert something which is also called as push. So you might want to push an element called 10. So that element 10 should come and get placed over here. Okay, and at times you might want to call pop. Should this pop thing take an argument with it? It must not take, right? Why it must not take? Because when you call pop, the element is always deleted from the top of the stack. Always deleted from the top of the stack. Okay, so it doesn't need to know that. What it should simply do is, if let's say your top was now pointing over here, it should simply do top minus minus. So what will it do? It will make your top point to this. And in stack, the universe of your stack is limited from the fixed end, which in this case is index 0, to top. It is just from 0 to top. There might be some elements above the top also, which you had inserted before and then you had deleted, but you don't really care about that because your stack is just from 0 to top. Okay, cool. So what would be important operations with respect to stack? So first important operation can be a push operation. So let's say there is a push operation, int x, and should it return something? No, need not return anything. So what line of code should come over here? Tell me one thing, can something go wrong while pushing? Underflow will not happen while pushing, but overflow can happen, right? Yes or no? It can happen because let's say the stack was completely full and then you are trying to push any element, so you can't do that. So for that you will want to write a function is full. So if you see that the stack is full, this will be a boolean returning function. In this case you will print some error. Otherwise, what you are supposed to do? So tell me one thing, once you have initialized a stack, an empty stack, what value of top would you want? So you can say that s.top is equal to -1. This simply says that the stack is empty. From 0 to -1 means completely empty. Otherwise, what would you want to do? You would want to do two things. You would want to do s.top++, and then at this index in this array, you want new element to be inserted. So for that you will do you cannot access array just by writing array, you have to access it by dot operator on this. So you will write s.array of s.top equals to x. This is the implementation. Similarly, you will have a pop method. So pop does not take anything and does not give anything. It simply removes the element from the top of the stack. So while popping, what can go wrong? Let's say the stack is empty and you are calling a pop. So that will be underflow scenario, right? So for that you would write a separate function called isEmpty. Now whenever isEmpty returns true, you would want to print error. You would want to simply say that hey, this thing cannot be popped. Otherwise, what will you do? Otherwise, can I simply say I'll do s.top minus minus? Yes or no? Apart from this, what can be other important function? Sometimes you might want to peek. Peek and top, these are two same functions. So I think in C++ this is called as top. In the inbuilt STL, it is called as top. So when you do top, it should simply return you the value of topmost element. It will not tamper the stack. It will not delete anything. It will not add anything. It will just tell you the value of the element at the top of the stack. Okay. So it should obviously be returning me something. Whatever it should return, that should be the data type of my stack. So here it is an integer. Okay. So it will be int top, and then do I need to check something over here also? Tell me that. Can there be an edge case with respect to top? And that is the most important edge case that people miss out on. Yes, it can be empty, right? So what if your stack became empty? So guys, when you are using your STL stack, never do s dot top, never ever do s dot top or s dot pop without checking whether your stack is empty or not, because in that case you will get underflow error. So if you see that the stack is empty, then you will print error. Only if it is not empty, then you will simply return the value of s dot array, s dot top. Now two more things remain. Is full and is empty. Is empty is used here also. So can you implement is full and is empty? How many of you can do that? You can do that, right? Because in is full, you will just check the value of s dot top. So if you see that s dot top has become equals to n minus 1, that means it is full. And in is empty, you will just check that your s dot top is equal to -1 or not. So those are, very easily implementable. What are the time complexities of all these stack operations? Order 1. So it might look that stack is a very, very efficient data structure when the operations are based on just one end, okay? Because all its operations are order 1. So that is a very important point.